You know, when I told my girlfriend that my presentation will be at 10:15 Sunday, she asked like, "But how are you going to do it when you wake up at noon at least every Sunday?" So I'm very happy to be here, and thank you for coming. I'd like to begin by asking you to think, what would you do if you could make your own Heroku? We are used to, and we love the expressiveness of our favorite dynamic programming language, and we're used to abstractions going up in frameworks and APIs. But recently, tools that let us control and program hardware are going in a similar direction, which I think is very interesting because it allows us to create new and better systems easier than ever. So this presentation will be about virtualization and provisioning and the tools you can use to create your own software platform. My name is Marko Anastasov. I'm a co-founder of Render Text, a company that has been doing mostly Rails consulting for over 5 years. And about a little more than 2 years ago, we started working on a continuous integration app because as we were doing test-driven development, we didn't find a service that could really work well for us. And you know, since we value our time, we didn't want to spend it configuring Jenkins. So last summer, we launched Semaphore, which was the first CI service that offered one-click integration with GitHub, and it could auto-configure a Rails project. And in general, we say it's built for speed and simplicity. And today it's used, you know, it's running thousands of private builds every day. So that's kind of the background, the experience that my talk is based on. I'd also like to point out that when we were starting doing this, none of us were like DevOps, and we didn't hire any. We were just hackers, always looking for like the simplest thing that could, you know, possibly work. So I'll try to give more practical insight rather than drown you with details. So let's begin. Like, what's actually a container? A container is a term that explains server virtualization approach that runs on an operating system level. So the host operating system runs the kernel and multiple isolated virtual machines in user space. So some people say it's like change root on steroids. So the OS is responsible for making sure that each container runs in isolation from each other and the host. And it can also apply various resource limitations and security policies, such as you may say a container can use this much CPU power or memory or disk I/O, and so on. This is different from full or para-virtualization. For example, VMware does full virtualization, which means that it does a complete emulation of the hardware and then runs a whole new OS on top of that. Para-virtualization is, for example, Xen. And it involves some kind of a bridge which sort of reduces the amount of work necessary, but they both involve running at least multiple kernels. And since containers do not need to do that, you may guess that they have, you know, much better performance. And this has nice business consequences, such as, you know, you can know exactly what you'll be getting out of your hardware. And you can also we can also begin to offer relatively high-speed computing services at, you know, acceptable prices. And so if your use case boils down to a requirement that you need to run some code in isolation, I think containers are a good fit. And the particular technology that I'm going to talk about is LXC, Linux containers. The project started around 2008. I first heard about it when I learned that Heroku is using that. And it requires a modern kernel, but nowadays pretty much any recent distribution can run it. And I'm going to use Ubuntu as an example. So you get started by just installing one single package. It's pretty simple. And then you have a number of command line tools that help you create and manage containers. So you can guess from the names, you know, ls, lists all running. You can create, start, destroy, and so on. So to create one, you use LXC create. You give it a name, and then you specify a template. A template is, in implementation, it's one gigantic bash script that you probably don't need to change. You can configure them later on, the containers. So for example, in Ubuntu 12.04, the Ubuntu template will actually install a basic server installation inside a container. Technically, what this does is create some files. Everything is a file. So there's a configuration file where you put your security policy and the resource limitations and network settings. fstab, pretty straightforward. And then there's a rootfs, which actually contains an entire new Linux. So you use then LXC start to just, the cool thing about LXC create is that it takes just like a few seconds. The first time it just needs to download some stuff, but after that it's cached, so it runs very quickly. And then with LXC start, it starts like almost instantly. And you can easily log in with some default credentials. So you're quickly in, and that's pretty much it. You have an isolated, I say it's a virtual machine basically, that you can configure and customize to your use case. And remember how it's all just files, so you can basically, when you're done, you can shut down, you can create a tarball and reuse it, which is pretty cool. So we're now at the point, yeah. So the best documentation that I'm aware of is Ubuntu's server guide, and the mailing list is also a good place to ask questions. So when you reach the point of actually customizing, you're wondering how you can do this most effectively. You can sort of do everything by hand the first time and create a guide, and then do everything manually, or you can act like an engineer and automate everything. I think there's no middle ground. You're either, if it involves some manual steps, you're still in the first version. So one tool that can help you do this is Chef. It's an open source tool for specifying system configuration. It's basically a Ruby DSL that's rather easy to learn. So you don't need to be necessarily a Rubyist to understand it. The main idea is to treat infrastructure as source code, to make it source code even. So it's a fairly recent idea, I mean, in terms of how much traction it's getting, but if you're a developer familiar with Agile, I think it comes pretty naturally. So the main principle is that you specify a desired result, and Chef takes action to put system in that state. And it does not attempt to redo this if the system is already in this state. So for example, if you want to produce an AMI image for Amazon EC2, you want to do this deterministically and repeatably, right, at any point in time. And it would be great if you could run all your kind of scripts without no harm on an existing sort of provisioned machine. And with Chef, you can do that. So the way you do things are recipes. Here we are sort of installing one simple package based on the OS. Again, this does not attempt to reinstall it if it's already there. This is another example where we're dealing with a directory. In Chef terminology, we're talking about a resource. So resources can be files, directories, packages, services. And here you can sort of see how you can mix things with the variables and pass some kind of attributes as parameters. The documentation about resource is the sort of the wiki page that I kept coming back the most when I worked with Chef. So when you're dealing with, again, system configuration, you often need to produce some files. You want to have your own version of MySQL configuration. Or maybe it's better to use Postgres, but anyway. So it's good that you can use ERB files in Chef's case. In case you're not a Rubyist, ERB is a standard library way of doing templating. And this bundle of recipes and templates and maybe some metadata is bundled in cookbooks, and that's how you distribute things in Chef. Again, whenever things are kind of defined and standardized, the great thing is that there's a bunch of open source stuff that you can reuse. So, for example, Upscode, the company behind this project, has a a lot of cookbooks that you can study and reuse. And there are other companies sharing their work as well. So when you begin, if you go like now to the Chef homepage, it'll try to teach you about a number of tools, such as Chef Client Server, and it may be a bit overwhelming if you have in your head a picture that you just want to run some scripts in a nice way on a new machine. So I recommend starting with Chef Solo, which is a Ruby gem that sort of lets you run cookbooks with no additional dependencies. And we're still using it, for example, in Semaphore, so I think it's perfectly fine. The idea behind this client-server thing is that you run Chef Client on a new machine that you're provisioning, and it sort of securely connects to a Chef server, which can be your own machine or the one you pay to Upscode to maintain, and sort of download maybe some sensitive information along with cookbooks. So since this was kind of hard for me to figure out in the beginning, for this presentation I created a sample repository containing everything you need to run cookbooks with Chef Solo. So you can check it out on this address. So by now you might be wondering, is there an even easier way? You know, what if I'm not maybe making a platform, but just want to virtualize a part of my infrastructure? Well, you might have heard about Docker, which is a project that has been getting a lot of attention lately. And there was an introduction talk yesterday, so I'm not going to give you an introduction. I'm just going to talk about it from the perspective of somebody who knows. Let's say you know about LXC, so you're wondering what does it do new. So the good thing about Docker is that it attempts to standardize a lot of things that I sort of recommended doing in the previous part of the presentation. So, for example, it's a defined thing what's a container image, right? So this enabled a pretty big already repository of open source container images that you can reuse and contribute to, much like you can do with Ruby gems or node packages. So you start by like getting the default Ubuntu image, which is kind of like the LXC blank installation that I showed earlier. So basically, Docker is an abstraction layer above LXC. So if I would like attempt to run this forever printing hello world script inside this container, it will first actually create an LXC container. But then it does one new thing, which is allocate a new file system on top of your existing file system. And this is AUFS. It's a union file system. And with those, you get ability to have shared read-only areas and then separate write areas for individual work. So if you would like run 10 containers, each one would share the same read-only part of the image, which is fairly large, and then write to disk just the bits that they do individually. So next up, it allocates a new network interface and assigns an IP address to container. So you can, pretty much immediately SSH into it. And this is good because with LXC, you have to figure out a lot of stuff about how networking works on a low level in order to get this to work. And finally, it runs your thing in the container, and then you have commands to sort of live tail the logs and so on. And there's one log. So this reflects the idea that Docker should be used to run individual applications and not entire systems. And I think this is an important point because Docker can be used to deploy traditional web applications. If you take a very simple kind of example, you're just getting started, everything is in one machine, the relational database, your app, and so on. You sort of think of these things as separate things, but there's actually no physical boundaries between them, and you're not very flexible about moving these components out of your system to a new architecture. But if you would sort of containerize each of these as like tiny executables, let's say. Then you have containers that do one thing like well, and then you're free to move them around anywhere. And then you can also use the same like bit exact version of the configuration for your production, staging, and on development machines. It also provides syntax for provisioning. So you can install stuff and so on, but the final thing, this like CMD instruction, actually defines what your application in the container is. So again, you can sort of do things manually, but you can also call chef from here. It's up to you. And another good feature is that there are incremental sort of version control-ish commands to keep track of all changes to containers. So every time you change something, there's a new snapshot that you can save. And again, this is much better than working with raw LXC, where you can have tarballs which are either completely working, or or they're not working, and you can just delete them, or you can hack your way around versions. If you need to frequently change things, this is really convenient. Again, well, it's not all so perfect. So Docker is a pretty young project, and its makers are saying that it's not really production ready yet. And by using it, you potentially expose yourself to a new layer of bugs. And although in theory it should be really portable and runnable anywhere, it actually works only on Ubuntu. There are ports, but ports. So this is why, for example, recent news about the collaboration with Red Hat is kind of interesting, because their commercial goal is to make Docker run on Red Hat Enterprise, but the side effect will be that Docker will be, or should be, runnable on any Linux distribution. And also, if you do start using Docker for application deployment, then there's some kind of new challenges. For example, what happens if I deploy a new version of my database container? How does the application learn about this new address? Or since containers are kind of meant to be short-lived, and like you just create, run things and destroy, how do you deal effectively with persistent data that needs to be persistent? But hopefully, there will be new tools that can address these issues. So generally, my point is that sort of we're getting a new layer of things that are hackable, right? If we can hack these things, then a relatively small team can, sort of create new systems in a short amount of time, and I think that's pretty interesting. So that's about it that I had. Thank you, and I welcome your questions.
So, questions?
So near the end of your talk, you mentioned that one of the challenges is connecting these Docker applications to each other. For example, the main web app of the database. And you could just use an IP address and a port with this. But of course, you'd have to somehow handle the fact that there would be a change in the IP address or a different port which this is running on. Is this in the scope of Docker, or is this never going to be in Docker, this sort of, switching a container to have a different IP address, or leaving the IP address in port and switching the container behind it?
Yeah. So you're basically asking, will it ever be Docker's responsibility to manage these connections between containers? I don't think so. I think that Docker provides commands that you can use to sort of query which containers exist, which are running, and inspect them, like get their IP, get their ports, and so on. So, like today, I guess you can sort of hack your way towards that with some of your own tools. I expect that there will be some tools to sort of that address this generally.
Any more questions? Well, if there is no more question, then thank you very much again.
Thank you.